This video presents an introduction to Failure Mode Effects Analysis, or FMEA. This material was produced under a grant from the Occupational Safety and Health Administration. By the end of this video, you will be able to define FMEA and describe how to apply it in design, process, and project procedures. You will also identify key FMEA terminology and develop a completed FMEA using risk priority numbers in a hospital nurse unit. FMEA is a tool used during the Analyze and Improve phases of the DMAIC process, which stands for Define, Measure, Analyze, Improve, and Control. FMEA is a structured approach to identify ways a product or process can fail, estimate risk, and prioritize actions to reduce that risk. A process FMEA captures the entire process and key inputs, identifies failure ways, and facilitates a plan to prevent those failures. FMEA has applications in design, focusing on product function, and in process, analyzing manufacturing or other processes, and focusing on process inputs, which is the focus of this video. It is also used in project to document and address potential failures during a major program. Key source material for an FMEA includes a process map, which outlines the steps and key inputs. This map feeds into the FMEA, which analyzes potential failure modes, effects, and causes. The FMEA Forms Analysis section details the process step, potential failure mode, and effects. It also includes the potential causes, current controls, and ratings for severity, occurrence, and detection. The estimated risk, or RPN, is calculated by multiplying these three ratings. A failure mode is the way a specific process input fails. If undetected, it can cause a negative effect. Anything an operator sees as wrong is considered a failure mode. The effect is the adverse impact on customer requirements, often external. The cause is whatever makes the failure mode happen. For example, a worn spindle is the cause, an out-of-tolerance dimension is the mode, and the part not fitting is the effect. Severity assesses how serious the failure effect is to the customer. Occurrence measures the likelihood of a cause happening and resulting in the failure mode. Detection assesses the likelihood that current controls will catch the cause or mode before the effect reaches the customer. Current controls are systematic methods or devices in place to prevent or detect failure modes or causes. Prevention-based controls include mistake proofing and setup verifications. Detection-based controls include audits and inspections. FMEA uses typical rating scales for severity, occurrence, and detection, typically ranging from low 1 to high 10. It's important to know if your company has specific rating scales and rules, especially for high severity scores. A key output of an FMEA is the risk priority number, or RPN. The RPN is calculated as severity times occurrence times detection. High severity scores should always be given special attention, regardless of the overall RPN. The RPN does not have to be limited to severity, occurrence, and detection. You can add other scores, such as an impact score for overall failure mode impact, an EHS rating for environmental impact, or an ease of completion score to help prioritize projects. A high detection score implies that catching the failure cause is difficult until the effect occurs. A low detection score suggests that you can catch the cause before it creates the failure mode, indicating a greater certainty of prevention. The FMEA model illustrates the chain from cause to mode to effect. For example, a faulty inverter is a cause, leading to an agitator that is too slow, which is the mode, resulting in an extractable that is too high, which is the effect. Note that the relationship between the failure mode and the effect is not always one-to-one. Multiple failure modes can lead to the same effect, or a single failure mode can lead to multiple effects. This slide shows a detailed view of the FMEA form, emphasizing the inputs for process step, key process input, potential failure mode, potential failure effects, severity, potential causes, occurrence, current controls, detection, and the resulting RPN. The action section of the FMEA form focuses on recommended actions to reduce the RPN. These actions should target high RPNs or easy fixes, and are documented with responsibility and completion month. The RPN is then recalculated with revised ratings. Completing an FMEA involves 9 strategies: determining failure modes and effects, identifying causes, listing current controls, assigning ratings for severity, occurrence, and detection, calculating RPN, recommending and taking actions, and recalculating RPNs. To get started, use process maps, cause and effect diagrams, and other relevant information. Select people for the FMEA team from various functions, both upstream and downstream, such as engineering, manufacturing, quality assurance, and HSE. You may now complete an FMEA exercise using provided files to practice the analysis section. Some practical tips for FMEA include doing it as a group activity, being prepared for it to be time-consuming, and understanding that activities are required, not just paperwork. Prepare properly for meetings, summarize often, and negotiate issues to ensure a successful outcome. In summary, FMEA is a step-by-step approach to identify all possible failures in a process or product. A key output is the risk priority number, which is used to prioritize actions to mitigate risk. Thank you for watching this video on failure mode effects analysis.